Hey everyone, welcome. It's wonderful to see you here today. I'm Bob Rogers. I am co-founder and chief scientist at BeeKeeperAI. I'm going to let Steve talk first, but I just wanted to set the stage for our conversation today. We're talking about how zero trust can enable the last mile in healthcare. And what's interesting, Steve and I spent quite a lot of time this morning talking about our views of challenges in healthcare, challenges around access to data, where that blocks our ability to provide efficient care or track what needs to be done across the community, or to actually do research and develop new diagnostic and operational technologies with AI. And it's the theme that emerged for me, and I'll be curious about feedback from everybody at the end, is that what you'll see here is two different views of data security in healthcare that are both non-traditional, but are both creating a very complementary way of creating value across the entire care experience. So I think I'm going to be very curious to hear the details of what Steve has to say, and of course encourage you to ask us questions. And the only other question that I would have is, I'm curious, are people, just raise your hand, are you working in a health system? Okay, couple. What about payers? And other policy or any other areas? Saw a lot of security. Mm-hmm. Security in general. Okay, perfect. So obviously there will certainly be some connections for all of you as we connect the dots here between these two ways of thinking about security in healthcare. So Steve, do you want to start?
Sure. So I have about 40 years of experience in doing lots of big data with sensitive data sets, and have come through several generations of artificial intelligence, and we shared some experiences earlier today about how that is, how difficult that can be. I think in the healthcare arena you have nothing but sensitive data, and if you're going to do something meaningful, you really need access to that in order to develop the right kinds of automation. And it starts with good statistical characterizations of what you have, and then what you can automate. And we talked about various trials and views of how you decide what to automate and what's worth doing, and performance, and what that means to business decisions. But I think the most important thing to realize, and this has been echoed throughout the morning and afternoon, is that data has a lifetime. If you can't really make use of the data in its lifetime, and as it ages, its utility continues to degrade, what can you really do with all that data you're collecting and protecting, right? So you need to get it to the point of action. So at SofthRed, we've come up with technology that we call Kaios. That's basically our own proprietary blockchain. It's a method for sharing information, decentralizing storage, to controlling access and fine-grained data access controls and service controls. And that software is called Kaios because the first democracy was in Greece, and it was the democracy, the little group was called Kaios. And so we are trying to democratize data, free it for the purposes that it should be used, and appropriate use is the guiding principle. So, we're able to insert policy controls, we're able to understand who can take action on what pieces of data, who can access what services and systems. So we often start with registering the entities that are going to be involved, whether it's individuals or people. They get authenticated, they're made members of the network. And you can think about this in an Internet of Things as also doing that with devices. So devices are also joining this special network. And we have a multi-server consensus protocol that we're using to arbitrate transactions and decide which ones are allowed to be used. We implemented this in a way that's really fast. So I think we could benchmark around 30,000 transactions a second. which is quite good, I think, for that kind of an operation. And then we achieve Byzantine fault tolerance, which means that basically 30% of our servers or so can be wiped out, and we can continue to operate. So this gives you some robustness with respect to error. It gives you robustness with respect to cyber attack. So if you have to take some number of your servers offline in order to patch them, or you're in the middle of a war, and we tried to envision that this morning, you know, in the healthcare world where you actually have cyber defenders who are actively engaged in trying to keep something from happening. This buys you the space and oxygen in order to do that. I think, you know, there's a lot of interest in our technology because it layers in over existing systems, so there's not a lot of need to rip out what you've done already in order to make use of it. And the way we've implemented our architecture in a modular fashion allows you to use whichever modules you think are important for your application. And you can start small and grow large, and then scale as your experience dictates. We're a primarily business-to-business function at this point, although we have some engagements where we've done both the front end and the back end kinds of work. I think you've all experienced, you know, going, and it's been talked about today, going to an office visit or going to the hospital and having records be incomplete. One of our use cases involves layering in the Kaios solution so that you can connect disparate systems in order to get and move towards patient-centered care, so that you get a much better sense of what's going on. I was recently in the ER with my mom, and the records were incomplete, and of course she's not feeling great. She's 91 years old. She's not feeling great. She doesn't really want to have these conversations with the doctor. Her information is coded, it's somewhere else, and it took quite a while to find it, and lots of consternation in the interim. So, you know, we all have our own personal story about how the dots don't connect. If you've done COVID testing, you've experienced it. Some of your tests show up in some places, some not in others. Your immunizations don't all show up in the same place depending on where you went to get them. So we feel like Kaios is going to help us connect those dots. It does the same for the Internet of Things. There was talk earlier today about sensors and sensor networks. We're able to fold those in as well and protect those. And I think it's going to be increasingly important. We talked about zero trust. You know, what is zero trust? And so it got highlighted by the executive order that was put out for cybersecurity. And the organization CISA, the Cyber and Infrastructure Security Agency, you know, has developed some principles and a framework for how to achieve zero trust that focuses in on identity and devices and networks and then your applications and the workflow. But primarily the number 5 item is data. That's the thing we all want to protect. So we feel like Kaios brings a lot to the table with respect to each of those components of zero trust. And zero trust is really about moving away from this network location-centered protection scheme to really protecting what's happening with people and assets and the processes that they're engaged in, their activities. So I think as we move to zero trust, that's what we're talking about, is adding in additional security that addresses those. So I think that, you know, Kaios is needed for achieving those kinds of protections, and our clients are engaging us in that way. How do we get good cybersecurity as we go through a merger and acquisition, or we, you know, acquire more hospitals, or whatever is happening in the business world? You don't want the systems that are supporting those activities to be in a laggard mode, you know, constantly trying to play catch up at great cost in order to achieve a single system. So I'll just leave that as a sort of an introduction. You know, so we're lightweight. We can move to the front end for IoT. We enable the AI work that needs to go on as well. So.
Yeah, and I'll be able to connect that dot just a little bit at the end of my exposition. So again, as I said, I'm Bob Rogers. The BeeKeeperAI story actually started about 3 years ago when I was expert in residence for artificial intelligence at the University of California, San Francisco Center for Digital Health Innovation. And I was working with my colleague who's hiding out in the back, Mary Beth Chalk. We were both at the Center for Digital Health Innovation working on the development of the world's first FDA-cleared AI on an X-ray device. And the starting point of that was using UCSF data to develop a suite of 25 algorithms that could reside on portable X-ray in the ICU, detect specific emergent conditions, and then trigger the right workflow responses to those conditions. And what we found was that it was relatively easy for us, I mean, looking back, it was relatively easy for us to create those algorithms on our data as a starting point. But getting it actually cleared by the FDA required proving that it could work on a large number like 5, diverse data sets all throughout the country. And that part of the project was immensely difficult. It was costly. It took us 18 months just to get through contracting with each of the individual counterparties that had data that we were interested in working with. So what we realized is we started out with the idea there's got to be a better way to do data sharing for the purposes of research and AI development. And then the moment that was critical for us, the epiphany was, wait a minute, this isn't actually a data sharing problem. This is a compute problem. How do you compute on data without sharing it? The beautiful thing is, simultaneously in the last few years, some new technologies have come out. You security folks will know about these. Privacy preserving computing and secure computing enclaves, which allow you to do compute in a very locked down way. So we developed Beekeeper around these technologies with the idea of facilitating access to data by algorithms without sharing. So let me tell you exactly what Beekeeper is and a little bit more about the details. So the principles of Beekeeper are data never moves from its origin. Data is never shared or seen by third parties. And at the same time, algorithm IP is protected. That is, if we're going to ask an algorithm developer who's spent, I mean, we've worked with companies that have spent $20 million to create a single diagnostic algorithm. If we're going to ask them to send their algorithm to the data, we've got to provide guarantees that their algorithm is protected. So the idea of Beekeeper and the workflow of Beekeeper is, imagine an algorithm developer who has an algorithm that they want to send to private data. So PHI, there's no de-identification, there's no modification of the data. It is the native data. Think of it as real world evidence wherever it sits. They upload their algorithm. Well, they encrypt their algorithm first. Then they upload it to the Beekeeper platform. Then they also create a data spec, which describes exactly what data their algorithm is expecting. So you can see there's a deviation between the sort of tracking data and controlling access in a sort of network view, which is what SofthreadDr is doing, and our view where there's a very specific data asset that's been created for a specific purpose. That means we don't have to do a lot of interoperability and worrying about making all data points work for all comers, but there is a layer of the data steward whose data it is has to match a spec. So the data steward creates this data asset based on the spec. They encrypt that data and they upload it to their Beekeeper node. So what is a Beekeeper node? It is a piece of infrastructure that is spun up inside the data steward's own PHI safe cloud environment. So think you've got your PHI safe area in Azure where you're operating on clinical data day in and day out. All your protections and your regulatory components are there. We're part of the Azure marketplace. You push a button and a Beekeeper node can spin up. Once that Beekeeper node is there, it's got a secure enclave inside it. So the data and the algorithm come together inside that enclave. The way to think about a secure computing enclave is it's like a vault. And whatever happens inside that vault, nobody can see from the outside. And in fact, even the operating system of the computer that's running that enclave can't see what's happening inside it. So it's very, very secure. Once the algorithm and the data are combined and the vault is closed, then they get decrypted. The algorithm runs on the data. And then whatever the agreed upon output is, and that's agreed upon between the two counterparties, then that's what gets output from the enclave. And that's the only thing that can leave the enclave. Typically for us, our first product is a validation product. So it is a detailed performance report about how the algorithm worked on the data. So, but there are also ways to train algorithms and to generate ongoing outputs from live data streams to create insights that are useful for the data steward. So couple other things to point out. Just so that I don't completely miss the blockchain thread, because otherwise you're going to be like, well, okay, he talked about zero trust, although I haven't yet, and security, but he didn't talk about blockchain. So here's the blockchain story. We capture a hash of every asset that goes into one of these calculations and put it on an immutable ledger. So we're tracking the transactions in blockchain. So that allows us to go back when the FDA says, hey, how do I know that this result that you're showing me was actually the one that you computed a year ago when you put in your submission? We can go back to the blockchain, look at the hashes, recompute them, and match it all up. So it's a very solid track record for whatever's happening inside the system. A couple of other nice attributes. We can bring down the enclave and spin it back up whenever we need to. So I'll tell you about a really interesting project that we did and how the actual flow and Beekeeper worked. But before I do that, I have to now check my other box, which is zero trust. So is it zero trust? Why is it zero trust? BeeKeeperAI is a platform that was explicitly constructed to be zero trust from the outset. So we have all the various granular access controls. We assume that the algorithm coming into the enclave is an adversary and is trying to exfiltrate data. And so we're locking down the communications from that system so that everything that comes out, like a report, is validated. Also, nobody can see each other's assets. So the algorithm developer cannot see the data. The data steward cannot see the algorithm. That ends up being critical because if you have an algorithm coming to UCSF, I guarantee you someone at UCSF is developing that kind of algorithm on their data. And so if there was a risk of IP contamination, then these projects just wouldn't happen. So there's a piece of enablement just due to the fact that we're isolating the IP. But then the third piece of the zero trust is Beekeeper can't see any of it. So we can't see the keys that encrypt all the bits and pieces are encrypted themselves before they go into our hands. So all we're doing is orchestrating the pieces, and the actual decryption of the data and the algorithm cannot happen unless they're inside a very specific secure enclave. That's one of the attributes of this confidential computing technology, is that you can't just decrypt willy-nilly. You actually have to decrypt with the key in an attested environment. So it's pretty locked down, and the result is a very nice zero trust infrastructure for bringing algorithms to data. A couple of other sort of features, and then I'll tell you about the cool sort of clinical outcome that results from all this. When I talked about a data steward putting their data in their Beekeeper node, we can actually have many data stewards. In fact, we do have a number of different data stewards. And so each algorithm could be validated on many different data steward data sets. Each of them is running in that data steward's infrastructure. So again, the data is not going anywhere. So that's really important. We can do federated training, although right now our products are much more about validation. Federated training is something we will be bringing out next year. And so that whole suite of things that you have to do to develop AI technology is coming. The customer story that I want to tell is about a large biopharma that we've been working with. They've created a treatment for a rare childhood disease that is very difficult to diagnose. So these kids, they have, it's a progressive disease, it's disfiguring, it's very challenging life-wise for them, but they look like kids with other diseases. So it's kind of a needle in a haystack. You've got this somewhat, this treatment that's very effective, but you can't give it to every kid. It wouldn't be appropriate to give it to every kid. You've got to figure out who needs it. So they came to us and they said, we need a way to develop and tune an algorithm that can find these kids. And so we set up a Beekeeper node for them at UCSF. They created an algorithm that they ran on the data. And then we did a process of, as they received feedback on how their algorithm performed and what were the details of where it was strong and where it was weak, they continued to refine and improve their ideas until they got to a point that they had an algorithm that could actually, with very high recall and reasonably good precision, find these kids in the clinical record. This is native data right out of the EHR. And so the final conclusion was, we had 25 kids that we knew about who had this disease. They were under the care of one of the world's specialists in this area. This biopharma took their algorithm and printed out the hashed records of the 10 most likely candidates for having this disease. And when that was checked against the actual clinical data by the expert, 4 of those kids were found to actually have this rare disease. I mean, this is a 1 in tens of thousands, hundreds of thousands of. So it's really a remarkable finding, and it allows us to bring the therapy to the kids and to deploy anywhere where you can set up a Beekeeper node. So we're super excited about that. This, I may even be able to say who it is, but this large I'm looking at Mary Beth, she's like, not yet,
yeah.
Not quite ready. They're very excited about what we've done. And so we're thrilled. There's a lot of other things that we're working on, but the core thing is, how do you get the algorithm to the data when the data has PHI? It can be retinal data, rare disease where you truly can't de-identify, genomic data. Social determinants of health is another example. So all of these types of data, you can't de-identify to build algorithms. You must work on the native data, and Beekeeper creates a path to that. And then that's the Beekeeper story. We're very excited about it. The connection to we were just talking earlier. I just was connecting the dots. If you think about it, these are 2 very different security views of how you access and connect to data. But interestingly, if we wanted to build a model on data where it is, but it's longitudinal, that is, part of the record is over here and part of the record is over here, how are we going to match that up? How are we going to ensure that the right controls and the right access? Well, we could query your system, build that meta for those records, and then the algorithms go to the data in place and do the compute. And that's a more complicated story, but just as an example, I think it's interesting how these 2 pictures, which are very different, actually could be very complementary. So that's the story for BeeKeeperAI, and would love to answer questions and talk to you more. Thank you. So right now, it's the encryption and decryption is typically done with standard AES 256, but we have libraries that can do a lot of different encryption schemes. So there's sort of if we set it up ahead of time, one could in principle do, if we were worried about like, a quantum attack on AES 256, we could do something more exotic. So we do have some different ways to do it. But that's the starting point is just standard encryption.
And we have a hybrid encryption scheme that we have patented that controls for the ordering of messages and making sure that things don't get out of order.
A little homomorphic component to it or something. Interesting. Mm-hmm. Yes. Right. So I'm just going to repeat so everyone can hear. So the comment was it's great that we're looking to make sure that the data can't be exfiltrated. And then what was the other? It's a great question. So the question was, for the rare disease, were the parents or the kids, was this consented research? Mm-hmm. And this is a really important point that I sort of skipped, and this is one of Mary Beth's amazing innovations. So when you talk about regulatory, IRB, and contracting, the contracting between us and the different health systems that we work with started out, typical contracting for this kind of data started out as 28 pages of dense legal and regulatory. It's now less than 5 pages. We actually don't even have to sign a BAA, although we will, because sometimes people are just more comfortable with that. But then on this consent side, we actually explicitly have a consent waiver from UCSF because the data is never being seen or interacted with by anyone outside. So it's actually an explicit IRB waiver, and as we go to training as opposed to validation, there will be some nuances to that. So we may trigger amendments to the IRBs that we have, depending on what's being pulled out of the enclave. So for example, if information were to come back to the clinician about the and I have an amendment to what I said, but if data were to come back to the data steward organization, then there would be an amendment to the IRB. In the specific case of these kids that were under the care of this expert, these were actually all consented patients because this was sort of supervised in conjunction with other research that she's doing. But from the UCSF point of view, the compute part of it can happen without explicit consent.
And I think that's a very important potential policy innovation that could happen. Mm-hmm. Is not having to go back to the well from ground zero to get permission to do something for, with data sets that have already been permissioned and put in place for that purpose. They're not leaving the store that they're held in. They're being used for the same purpose they were gathered for. To me, there's a lot of room there to speed up the process. If we were able to get policies to actually be implemented.
Yeah, no, it's a great point.
in a way that allowed that to happen.
In fact, we can reuse all the contracting IRB for anyone that we work with once we've done it. Yeah. So you had another question. Mm-hmm. Yeah, it's a nightmare. Mm-hmm. Yeah. Yeah, so the comment was the direct connection and the ability to find information in the record can very significantly improve the experience for the patient when we're sort of closing that loop automatically. And yeah, our vision, there's this whole piece of it about deploying algorithms so that you have those direct connections that we're actually really excited about. And I think we talked about this earlier. Regulators will be, I think, very excited about this ability to have algorithms running in an enclave and be able to track performance and drift. Because, I mean, I always like to quip, it's machine learning, not machine learned, right? You have this ongoing process. You want to watch for drift. You want to update when care patterns change. So yeah, that whole being able to speed up that cycle and be able to find those key findings is super exciting. Other questions or comments? Anything? We're getting the shepherd's hook here. So thank you on my behalf. And
yeah, and thank you very much. I appreciate it.
Great job.